Hello, my dear students, class 10. I welcome you all to our channel Mind Mapping. On request of some students, teachers, and parents, we are going to teach today a concept that is chemical equation, some special features. Today we shall discuss the special features or characteristics of a chemical reaction, and that is exclusively meant for class 9th and class 10th of CBSE and Odisha board and other state boards. So never be confused, please stay tuned, please follow me, and if you have any doubt, any difficulties, you please ask questions. Please feel free to raise your voice to ask questions to make your concept clear. Okay, so we have taken some examples. So these are the bullet points you see, and this pattern is followed in CBSE examination. Please be sure. Okay, so a chemical equation, simply you can say it represents a chemical reaction. Okay, so a chemical reaction is represented or expressed or written by a chemical equation. This is a very simple logic. Even in mathematics, we also write mathematical equations, mathematical identities, and mathematical expressions. We shall discuss all these in our mathematics program or mathematics class. Okay. Now, the first point, we have taken an example for your concept, that is when hydrogen reacts with oxygen, a new substance is formed. So you know that is a change in substance, change in state, and a new substance is formed in a chemical reaction. So now a new substance is formed that is called water. Okay. Now you see we have written hydrogen and oxygen when they react, when they combine, okay, the product is water. Okay, so this is a simple word expression, but this is the expression by chemical for molecular formula, molecular formula or formulae. You see, so hydrogen, this is the molecular formula of hydrogen, but H is the symbol of hydrogen. So we shall discuss. So whenever we write the different elements or compounds in a chemical reaction, we have to write them in their molecular formula or formulae or formulas as you call it. Okay, now you see this is the molecular formula of hydrogen and this is the molecular formula of oxygen. Now this is the one molecule of water. So we can say, so simply we can say when hydrogen reacts with oxygen, water is formed. Simple. Now you see a chemical equation. In this equation, you see, let us actually look at this point. It has two parts, and this part and this is the left hand side part, and this is the right part. In the left part, the means formula that are written, these are called reactants. Reactants, here two reactants, one is hydrogen, another is oxygen. Two reactants, they react, they combine to form here one product, single product. This product is one. Okay, this is an example for you. So we have taken, so two sides you see LHS. LHS means the left hand side. Even in mathematics, we have, you have seen, and we have also seen, you have to solve the LHS and RHS, left hand side and right hand side of the equation. Equation means mathematical expressions. Okay. So in LHS left hand side, what we write? A reactant, if it is single, or a reactants if it is two or more. And in RHS, what do we write? We write product if it is one single, or more than two we write products. Okay, here it is single, we have written product, this single product. So let us come to this point. This calcium carbonate, solid form, solid state. You know, in chemical change, in chemical reaction, when change of state of the matter, change of the state of the element takes place. Okay, that you know. When calcium carbonate, this is called calcium carbonate, otherwise called limestone, and it is also called chalk. When it is heated, when it is heated up, so you see two compounds are formed, and here is a compound, and this is the molecular formula of calcium carbonate. It is the one molecule of calcium carbonate. Okay. So now the product is single. Sorry, reactant is single. One reactant on the left side, and the right side you see two products: calcium oxide, that is called quicklime, and carbon dioxide, that is a gas. Okay, carbon dioxide. Okay, you see here calcium carbonate. This is here one reactant. Now you see here. Let us compare the first case and the second case. The first case, in left hand side we write, actually we find or we observe two reactants, but here we observe only one reactant, single reactant, and it produces two products. Okay, now you see two products: calcium oxide quicklime and carbon dioxide gas. Okay, two products, left right hand side RHS. Now clear? Then we have taken another example to explain, to make your concept clear, whether the reactant is single or two or more, or the product is single or two or more. Okay, so come to this example: the zinc plus sulfuric acid. When zinc granules, when react with the sulfuric acid, zinc sulfate, the salt, and this is hydrogen gas. The hydrogen gas is formed. Okay, now you compare the left side two reactants. Okay, left side two reactants, the right side two products. So this is another exception, and you compare three. This is the two reactants, one product, one reactant, two products. Here two reactants on the left side and two products. Okay. Now the question arises: when two or more reactants are in a chemical reaction, how can we write? Well, we have to use this symbol. This plus symbol is to be used between two reactants or two products. You see, plus sign used two or more reactants, and this plus sign also used in two or more products. What in mathematics? In mathematical equation, that is plus, minus, and multiplication, division, brackets, line brackets, all these signs or symbols are used. We shall discuss in our mathematical topics when we discuss. Okay, now proceed on. So this is very important. Okay. And another thing you see in mathematical equation, means mathematical equation, and we use this type of sign. This is called equality sign. Means left hand side is equal to right hand side. But here, instead of equality sign, this is an exception you have to remember, and this was asked in your previous CBSE question paper. Okay, and an arrow mark is given here. Okay, an arrow mark is given in case of chemical reaction or in chemical equation. So what does it indicate? What does it imply? What does it reflect? Or what does it show? Okay, means that arrow mark indicates the overhead. You see the overhead, that points, that indicates the direction of the reaction. Okay, and the products, you see this arrow mark indicates the product water, and this indicates the actually the direction of the reaction. And this question was asked, please be careful, this question was asked in your previous CBSE examination. Okay, and why this arrow mark, not why you cannot equality sign? Because in all cases, in all chemical reactions, the left hand side, the number of elements in the left hand side of the reactants are not equal with the number of elements in the product side. So we have to make them equal. So that will be discussed in our next point. Okay. Now you see elements or compounds. Here is the element you see. Element or compound. You see the compound calcium carbonate, and here is the compound sulfuric acid. Element, zinc is the metal element. Okay. Element or elements, compound or compounds is or are written in a chemical equation. Elements or compound, elements or compounds or element or compound are written in a molecular formula. You see the molecular formula, you see. Is the molecular formula of calcium carbonate. This is the molecular formula of hydrogen. This is the molecular formula of oxygen O2. Okay, and the zinc is the molecular formula of zinc, and this is also the symbol of zinc. Okay, so that you have already learned in class 9. Okay, so are always written in their molecular state, molecular formula or formulae or formulas. Okay, if it is single, you see it, the molecular formula. Okay, and this is the molecular formula, and this is the molecular formula, and this is another point, very important point. And you see that chemical equation, any chemical equation may be skeletal or balanced. Then what is skeletal? Means with a skeleton. The skeletal means what is skeletal? And here is a question, and what is balanced? Please look at here. Please, Ankita, please look at here. And Sampratika, you are very actually intelligent. Actually, you may ask any question if you feel any doubt. You see here. We have taken two examples to clarify your doubts. We have two examples. We have taken two examples to clarify your doubts. Okay. Skeletal, you see. So magnesium reacts with oxygen. Simple, you see. Magnesium reacts with oxygen, and a compound is formed that is called magnesium oxide. That is given in your textbook. Actually, this reaction is given in your textbook. Okay, magnesium oxide, and this is an example of skeletal reaction. Why? The logic is given here. Okay, skeletal equation, and skeletal equation is to be balanced. Okay, why it is skeletal equation? You see that we have explained here. In skeletal equation, you see Mg reactant. You see reactant side. This is the reactant side, and this is the product side. Let us count the number of elements. Number of elements: magnesium here 1, reactant side 1, and oxygen 2. Okay. Now 1 and 2. And the reactant side, sorry, product side, you see right hand side RHS Mg, number of atoms 1, number of atoms of magnesium 1, oxygen 1. Okay. Now you see this is okay, 1 1 equal, but actually 2 1 unequal, not equal. So when the number of elements in the reactant side are not equal with the number of elements, the number of atoms of the elements in the product side, this equation is called skeletal. This example we have taken from your textbook. Okay, and this point is very important. A skeletal equation is to be balanced. Otherwise actually this will not indicate this will not indicate the correct form of the equation. Okay. Correct form of the chemical equation. A skeletal form is to be balanced. Okay. There are several methods. We shall discuss in our next video how to balance a skeletal equation. Okay. So now you see skeletal equation to be balanced. Reason why to be balanced? This question was asked. Because you have already learned the law of conservation of mass in class 9. Okay. So the mass is neither created nor destroyed. So as per this law, the mass of each element in the reactant side or RHA side should be equal to the mass of the product side. So for that reason, we have to balance a skeletal equation a skeletal chemical equation. Okay, so we have already balanced actually that equation. We have balanced. Example we have taken. Now you see 2 Mg plus O2, 2 MgO. Now we can say 2 magnesium, 2 magnesium molecules react with you. Two atoms of oxygen, two atoms of magnesium react with two atoms of oxygen to form two molecules of magnesium oxide. Here, one atom of magnesium react with two atoms of oxygen to form one molecule of magnesium oxide. Okay. Now you see here actually in this case actually this is balanced one. This is the skeletal. This is the balanced. This is balanced equation. Okay. Now you see Mg number of atoms you please count 2. Okay, 2 and oxygen 2. This is the reactant side. Now product side, right hand side product side. Okay, you see magnesium 2 MgO, 2 is multiplied. Okay, 2 Mg magnesium 2 atoms and oxygen also 2. So here actually there is a confusion. 2 MgO means 2 is multiplied with Mg and O. Okay, so 2 Mg and O2. 2 Mg and oxygen also 2. So here 2, 2. Now you see the number of atoms of the reactants. If we compare 2 magnesium atoms in the reactant side and 2 atoms in the product side, and 2 atoms of oxygen in the reactants and 2 atoms of oxygen in the product side. So that the mass of magnesium plus the mass of magnesium of the reactant side is equal to the mass of magnesium the product side. And the mass of oxygen in the reactant side or LHF is equal to the mass of oxygen in the product side. So these are some of the special features of a chemical reaction. So as a beginner, you have to follow all these points and you have to remember all these points. And if your concept is clear, then our next topic, and the next topic actually in question here arises, all equations are not means balanced. So an equation may be balanced, already balanced. I have taken actually an example perhaps for you. Somewhere actually I have taken here I have taken actually, you see carbon, you see CO2, CO2. Now you count reactant side carbon 1, product side carbon 1, at number of atom carbon, reactant side 1 and product side also 1, and oxygen you see O, reactant side 2 and product side also 2. This equation is already balanced, not skeletal. That's why our point of discussion is in all equations, chemical equations may be skeletal or balanced. If it is skeletal, we have to balance it due to the law of conservation of mass. So this is all about our discussion, basic discussion, fundamental discussion. Next, the question comes to your mind means when a chemical equation is skeletal, how to balance it? What are the steps? What are the methods? What are the techniques? How to balance it quickly? And what are the tricks? We shall discuss in our next video. Thank you for watching. Please stay tuned and please stay tuned to watch our next video. Thank you all.